In this video, we will carefully solve a problem from current electricity, taken from the IIT JEE Mains examination. Welcome to our numerical series on current electricity. Let us begin by observing the circuit closely. We have a battery, a network of resistors, and a capacitor connected as shown. Our objective is to determine the current flowing through the circuit. Now, an important concept to recall here. In a steady DC condition, a capacitor behaves as an open circuit. This means that, after a long time, no current flows through the branch containing the capacitor. Do take a moment to reflect. What would happen immediately after the switch is closed, during the transient phase? You may share your thoughts in the comments. Although for this problem, we will focus only on the steady-state behavior. Since the capacitor behaves as an open circuit in steady state, we can safely ignore the entire branch containing it, as no current flows through that path. This significantly simplifies the circuit, leaving us with the reduced network shown here. Now, observe carefully. The 3 ohm and 6 ohm resistors are connected in parallel, as highlighted. To proceed, we replace this parallel combination with an equivalent resistance, which we will denote as R1. Using the standard parallel combination rule, this equivalent comes out to be 2 ohms. Replacing the 3 ohm and 6 ohm resistors with their equivalent, the circuit now appears as shown. On closer inspection, and after a slight rearrangement, we observe that the two 2 ohm resistors are connected in series, as highlighted. We can now combine them into a single equivalent resistance. Let us denote this as R2. Since they are in series, their resistances simply add up. So the value of R2 becomes 4 ohms. Now, let us focus on the next step. By rearranging the circuit slightly, we observe that R2 and the 4 ohm resistor form a parallel combination, as highlighted. We replace this with an equivalent resistance, which we denote as R3. Evaluating this parallel combination, we obtain the overall resistance of the circuit as 2 ohms. At this stage, the circuit reduces to a very simple form, a 2-volt source connected across a single 2 ohm resistor. Applying Ohm's law, the current in the circuit is equal to 1 ampere. Therefore, the current in the circuit under steady-state conditions is 1 ampere. And with this, the solution is complete. Thank you for watching. In the next video, we will solve the problem shown on your screen. If you found this helpful, please like, subscribe, and share it with your friends. And let me know in the comments if there's a specific problem you'd like me to solve next.